The hell? There you go. The recording's actually in progress, maybe. And if I hide my self view, I don't have to look at myself. You know what it is? I have a kitten now, right? Every possible, there it goes. Excuse me. Every possible thing that goes wrong with my setup happens because the cat gets behind my computer and just, messes with the cabling. And then everything was good for like 2 years without a touch. And then every time I set them back up, the
Instead of
wires are
fuzz
tangled
testing,
now,
it's
they don't
fluff
reach, so it's
testing.
pulling the thing sideways and the mic gets weird, and never mind, I'm whining now. But yes, the kitten is very cute, very fun, and will just shred your cables. So there you go. Yeah, all of this fun stuff shows up on YouTube in an hour or 3 or something. Fine. So we're on the hunt for topics this morning, and I claim that we sort of kind of maybe thought of one with York doing incremental compilation things and LSPs, but I don't really care. Oh, no, that was because we were talking about the whole generic monotonic improving algorithms. What is the basis for our monotone analysis framework, and how they apply to make systems, and how they apply to incremental compilation, and how they apply to conditional constant propagation, and how they apply to whatever. So this is a broadly applicable, easy topic here. And we were somehow doing LSPs. If no one cares, we'll take a different topic.
Let's talk.
Just do that one a little bit more. That one
Yeah,
is.
I mean, I can add some background there. Basically, the context there is that my compiler currently uses LLVM, which is dog slow, even if you don't apply optimizations. And we're talking 85% of the compile time, basically, with the remaining 15%, I'm guessing largely being due to it just not being optimized. And that's where, I was looking into incremental compilation as one approach, because in this case, it's like I don't control LLVM, so there isn't really much I can do to make it faster other than simply give it less code. But that means having to write an entire optimization pipeline prior to LLVM, which then kind of raises the question, why are you still using LLVM? If you have to do those optimizations just so LLVM has less to process so it's fast, that then raises the question, well, should we maybe replace it? But so my first step there is to see, okay, let's say we keep it. How would I go about making this incremental? And the idea I had there in my head was that because LLVM takes up 85% of the time, making a fully incremental compiler is somewhat overkill, in the sense that making, say, type checking incremental and things like that, it matters less when that's only 5% of the whole compile time. Of course, that ratio will change if the LLVM side of things gets faster. But so I wanted to start with basically this idea where say, hey, if I can somehow figure out that an object file produced by LLVM is up to date and doesn't need regenerating, can I just skip that whole file, basically? And in the best case scenario, that means a reduction of 85%. But that's like poses some interesting.
That's like a 6x speed up. It's pretty decent.
Yeah. Because essentially what I did, I basically chased my compiler so that I just say, oh, if the object file exists, just, leave it. Which of course only works if you can guarantee it doesn't change. So for this test, I made sure that they were all compiled initially. Basically to see, what is the best case scenario? And the best case scenario is LLVM doesn't have to do anything. Which means I went from I think it was 2.2 seconds, whatever it was, to I don't know, let's say 200-300 milliseconds. But doing that introduced some interesting challenges. For example, in my current strategy, when I generate symbol names for the object files, they include these sequential identifiers in them, which are the identifiers I use to address types. So some random class might have identifier 42, for example. Then when I generate the symbol name, it sticks that 42 in there. And that was mainly so that when types are specialized, they automatically get unique names because they also get unique types. And so I wouldn't have to use this sort of symbol mangling scheme where I take all the types and generate some sort of hash. And basically, it was easier. But that introduces this interesting problem where if the order in which you process files changes, so do those sequential IDs, which then invalidates your object file, even if the code is actually the same. Like it's just the names that change. So it's the first thing I figured, okay, probably have to change that scheme to use some sort of
It's a typical
hashing
path
approach.
flattening problem, right?
Yeah.
Like,
Right.
Yeah.
But then there's this other interesting problem where because I do type specialization, what sort of happens is you have, let's say, two modules, A and B, and A defines a generic type, and in B you create some sort of specialized instance of it. In other words, A defines array, and in B you create an array of string. What my compiler currently does is when it creates that sort of specialization, it basically sticks the sort of type definition of that in module A, because that's where the generic type originated from. Now, in my compiler, it doesn't really matter where you stick it. It's more that when you translate that to LLVM and eventually object files, you have to put those definitions somewhere in some module so it can generate code from it. And I figured, well, just stick them in the module that the original type was defined in. But that creates this problem where, in theory, you can run in this case where if, say, A, the source code of A is unchanged, and then you have module B and C, B is also unchanged, but C changes. If that creates a specialization in A, you have to flush the cache of A. So you have to regenerate that object file. And if that happens to be big enough, that can actually be quite wasteful. And you can do this other approach where instead of sticking them in sort of the original module, you stick them in the one where the specialization is first created. But then similarly, you can end up with these sort of implicit dependencies where if it used to be defined in B the first time, and all the other object files just refer to it, but now because the order of files or whatever has changed, it's now defined in C.
Put it in its own thing.
Right, but so there's a scheme where you need to, essentially what it comes down to is you have the sort of traditional dependencies of A imports B, and therefore A depends on B, and thus if B changes, A should probably also change. But you also end up with these sort of, kind of depending on how you do, these sort of inverse dependencies, where it's like, hey, I did something at the bottom, so now I have to change somewhere up more at the top.
No, well, okay, so from what I understand, if A defines array, and you put the generic array code into the A object file, B makes a string, so you put the array specialized to string in a special .o that's name mangled uniquely to array specialized to string. So that one depends on the first time somebody sees it, which is B,
Right.
but C does also array of string. So C also picks up the dependency to this magical .o file. And as they're both defining it, it's the other way around. The .o picks up from either of A and from B and C. And
Right,
A,
so,
because A defined an array.
Right, so the idea one there is basically for every specialization you generate a object file.
That's what I'm suggesting.
Right.
Yeah.
But then you end up with this problem where if you write those all to disk, because you have to pass into the linker, you end up with like 5 million object files.
Why do you get 5 million specialized types?
No, either way, the number of object files will then basically be equal to the number of essentially modules plus the number of specializations of types. Either way.
Yeah.
You end up with a lot of object
specializations
files.
Of types, which I would imagine would be scaling linear in the count of modules you have.
But then the question there is like, okay, I don't know generally how linkers behave performance-wise as the number of modules increases. Like I suspect gold, for example, is quite terrible. It doesn't do anything in parallel. LOD does some things in parallel. Mold does it better, but you end up with this case where simply by splitting things into modules, your linker performance may go down. I don't know.
Oh,
Yeah,
add the
you have to
linker
remerge them
performance
into
with
libraries.
add your linker costs to your LLVM execution costs.
Right. I think ultimately for me the desire there in a sort of hypothetical future world is you don't have a linker executable that you feed a bunch of object files. What you have is a linker library, and you tell it, here's a gigantic pile of functions. They're just stored, they're sort of data structures or whatever. Somehow generate an executable out of this rather than sort of shoehorning it into individual files that you then squash together.
Reason to go to individual files, I'm not saying it's the right reason for you, but the reason to go to individual files is because you get the obvious incremental update, incremental build situation. If you don't
Right, but
touch a
so
specialization, you don't touch the file.
right, so in theory, in this sort of hypothetical fairy tale world, your caching mechanism probably wouldn't be at the file level. You would cache things at, I don't know, the type or function level, but it's something more
You
fine
have to
grained.
store the cache somewhere, so it shows up.
Right, there's always a chance, but the idea there is basically if one function in a
Yeah.
module changes,
Yeah.
but it only changes its body, it's kind of stupid that you have to regenerate the whole file essentially, right?
I understand you. I'm just
That's
saying
the problem with the O granularity, right?
pick your granularity level. Yeah.
Right.
So Cliff's on the right track, I think. And Yorick is just uncomfortable with the fact that there'll be 5 million files. My suggestion is just get comfortable with the fact that there'll be 5 million files.
Ask the linker how fast that is. And linkers have dealt with this problem for a very long time, so it might
Right.
not be so bad.
Or it
No,
might be terrible,
Or
but
it might
Because
there's only one way to find out.
right.
Right.
And you could sort of put a middle ground where you say, hey, we don't put every specialized type in its own file, but we say,
But now you're killing your incremental.
Yeah.
no, in the sense like you can sort of group them based on whatever.
Well, you're making an adjustment of how incremental you are versus how fast or slow the tool is when it eats tiny small things
Right.
or one big lump.
So
And
You
I
could
would
literally
ask that
just
question before you get worried about what it is. Like ask the performance question. Do
what was
one
it, Shaw?
thing and then go
you
performance
could
it and then come
literally
back around.
just take a bunch of things that haven't changed in like 10 builds and put them into a .lib file if you're really scared of having a lot of files, and then instead of recompiling them just unlib the lib file and just edit it, because we can do this nowadays. Like we handle 5 million object files fairly commonly. It's just they're in one .lib file. In fact, you can split a lot of object files and shared object files into just a .o for every single thing for some compilers. I don't know if LLVM does it, but like there are tools that can like turn your 1.0 file into like 5,000 if you have 5,000 relocatable symbols in it, because that's what a relocatable symbol is. It doesn't matter where it is or what file it comes from. It just matters that it has the same name. And you could literally just merge .o files that are like not been changed, like your standard library. No need to have that be incremental. If you're changing your standard library on that not much of a basis, just put it all in 1.0. But if you're like it, you have to like do some like specialization on the human level with this one. Like if you're scared of too many files, just put them in an archive. Linkers handle .lib files, .a files, whatever we call them nowadays.
Yeah.
I think I heard Zig doing hot patching on the binary. Like
Okay.
I don't know if it's like a beta feature, but I think I heard something about like changing the actual binary.
When you say hot patching, you mean changing the disk or just changing after loaded? So hot patching in my head is like you loaded it.
It's not hot patching really, it's just binary, like patching the binary. Basically what they do is every function gets a bit of padding like at the end, and then if the function grows or something, like if you modify the source code, you add some new instructions or something, you can just patch the binary and then you don't need to relink it. So basically fully linked final binary gets rewritten because there's a bunch of space left there.
Yeah, I think I just mixed it up in my head. I didn't mean to say the hot.
No, I didn't understand. I think I got it now though. That just
Yeah.
They left
No,
room for a delta change of the function. You swap out one function for another in the same binary or whatever your granularity is.
Yeah, and so this, there's obviously a bunch of solutions there. Then I sort of took it. I was like, okay, let's say you implement this at the object level, so the last stage. How would you sort of extrapolate that to earlier stages of the compiler? Because at some point, maybe when you have more optimizations, you want to do incremental compilation there. And that's where things get kind of tricky. That's kind of what I asked Cliff, because I use sequential IDs for types, which means ordering is important.
Yeah, it's a go to name mangling and just get rid of that dependency.
Well, not on the object files, but if I, my type checker, as it defines types, the AST doesn't refer to them using pointers. It just says, oh, this node has type 42. And that's
that was
really
the pretty printing of types. So when you get done and you're in memory in a single compilation unit and you want to spew something out, you don't put the numbers out, or you admit that the numbers that go out are self-consistent within what you wrote, but they're unrelated to the next compilation unit. So when somebody wants to read those wad of types in, they'll need to renumber as they go. That was what I understood.
You could literally
you and I were
use
doing.
like a tree, like let's say you have like type 41 and 44, or 44, like 41 and 43, and in the middle is 42. And 42 has now become three separate types. You could literally store, okay, between 41 and 43, there are now three numbers that are like 41, and then this sublet, like you could do a tree structure where you just like, hey, it's not just a number, it's a number and then
That's what I was
some.
saying earlier. It's
Or
a
like a
path
linked list.
flattening problem, but because he's working in Rust, integers are super handy.
Oh,
and
I
pointers suck.
Right.
Yeah, so it's I spent some time looking at that, and as far as I understand, assuming you want to have this, the first problem is basically a thing called the ABA problem, where ABA problem, where you have a number and it used to point to A, but now it basically points to B because things have sort of shifted around. And
well,
so
the ABA is it points to B and then it pointed back to A.
Right, so
you got the wrong
whatever it was.
A. Yes.
But so as far as I understand, you kind of would end up with a system, basically SQLite, being your sort of storage or caching mechanism, where and not like actually SQLite, but the basic idea where your IDs aren't actually indexes to arrays, but they are like indexes into basically B tree index of some sort, something similar. And that then contains the actual indexes. And then as you sort of load things from disk into memory, you would sort of rewrite the references to those IDs according to that index.
You said a bunch of things that were, in my head, were almost right. So there's, you build up some structure and it can have cycles and sharing and whatever, and you're using some way to index between them with pointers or integers. It doesn't really matter. You want to serialize that to disk. You can write that out that way using those integers directly to refer to other parts. But when you read it back in and you're reading it into a namespace which already has the possibility of those same integers, you have to keep those two namespaces separate and rename things as they load in. And so when I said I have a bijection on my type pretty printer, that's exactly what's going on. I have integers and pointers, but if I ignored the pointers because I'm Java, I can use pointers, but I'm just using integers, fine. I have a typed graph that's complicated. I go write it out. My version of writing out, I get a little more clever and I don't put any numbers in except where I have sharing and cycles. And then I have to have a number so I can reference forward and backwards things. Okay, so some numbers hit the disk. Then when I read the thing back in, I look for those numbers and those sharing points, but I know I'm going to renumber them. And there is just a hash table that renumbers this pointer I got from disk to whatever new number I asked for my current type system. So there is a guaranteed renumbering has to happen somewhere.
So that's one alternative. Another one I used, the only incremental compiler I ever worked on, I just kept adding to the end for the incremental compiles. And then there was an option on the compiler that said compress, and it would go and renumber everything explicitly at that point. It was fairly expensive. And so, in other words, if you have a cheap global numbering system when you pick up to do the increment, anything that you're creating new that doesn't already have a number, in other words, you just keep adding and adding and adding. It's an option. I don't know if it works for you, but just an idea.
Separate compilation, but you want everyone to be in their own numbering space. You'll have to come up with some strategy. Whereas what I'm saying is you're just going to renumber them anyhow, just renumber them.
Yeah, and then I believe for that, you would also need a mechanism to say, to essentially map symbols in the source code to basically both the old and new IDs, which means you. So the idea being is if you have a module where you define the class person, and the first time you compile it, your compiler says, "Oh, person has ID 50," right? The second time you compile it, some other file was compiled first, and now it has ID 60.
Yeah.
What you need to know is, hey, that person used to have ID 50, now it has 60, which means
but you don't have to do that. You have to know you have person, and what I read from disk was 50, but in my current namespace it's something else, and I'm just going to map it on person, and then I don't even need the old number at all. I just need person. That's
so I was thinking that if that module hasn't changed, so there's two strategies you can do there. You can say, hey, we just read like we always wait, hold on. My thinking was basically if the module that has this personal class doesn't change, I don't want to somehow have to redefine its type. I want to be able to, to load it on a memory disk. Sorry. But then we need to make sure that if we need to know basically, hey, what were the old IDs that we now have to remap to this newly made thing or cached or whatever, right? But for that, you need to know, hey, if I load person from this module, it used to be this type. So you need some sort of mapping where okay. I lost my
index.
here.
So Yorick,
when you
what you're looking for. Sorry, I was going to say what you're looking for is a per O file index that says
that's what I'm
yes,
that
says
with this O file, if you see this number and you don't know what it is, I'm going to spell it out for you here so you can use this non-efficient lookup mechanism if you have to find it later.
Well,
because Cliff, oh, sorry, well, I was going to explain Cliff. He's got different versions on disk. So some of his O files are version 1, some are version 2, version 3, he's not rewriting them on the fly, all of them. He's just writing the latest version.
I'm talking about a general solution to the general problem, and it would work with multiple variations of .o files. There's some mapping you're doing where you match name to name because a person in this module and a person in that module is the same person because that's your names. So you have to match names to names. Within a self-consistent type that was using names for the person, you may also have other pointers to other things that don't get globally exposed. Names are all just self-local. You're just using your numbers to point to each other internally within them. The names get stripped out because no one else can see the private names. You don't care. Now you have some hard links to the outside world that have names like person and salary and age. And you have some anonymous names that are just numberings that said type number 17, type number 25, type number 32, whatever, because you're using Rust and the type index goes to the type structure, and there you go. Okay, when you load that in, you're going to renumber all those anonymous inner names, but all the person, salary, age, string names are going to have to hard map to whoever else you're loading into, version of the same thing. While you're renumbering and person already had a number 2, you give it a new number because everybody gets a new number on the load. If you know you're going to get a new number on the load, it's part of your loading strategy. It's an easy linear time walk to just renumber as you load.
I have a question. Does that mean that when you rename like anything, like a function or a struct, or then you break incremental compilation?
No, it has nothing to no. Because this is how I take a graph description on my memory from this object file, I write it to disk, and I load it over here. I get the same graph. It's just the internal numbering is just how I represent the graph. So incrementality of the execution, the changing of the types, whatever, that is based on changing the structure of the graph. All I'm doing is an alpha rename of the graph. And your incrementality is independent of an alpha renaming. Want to be able to rename a whole graph without changing its shape at all. And once you have that solved, then that does the whole, I loaded it, I stored it, I loaded it again. I have a new graph. It's the same as the old graph in shape. The fact that internally the numbers all changed is all an internal, it's an internal thing.
If it
The
behaves
idea
the
is
same,
York.
it doesn't need to recompile.
I'm sorry. Both of you talked at once. It's Shaw first.
If it behaves the same, it doesn't need to recompile. That's my
Yes.
belief.
Yes.
If all that changed is a bunch of numbers somewhere and it just behaves the same and the object file will do the same thing, there's no need to recompile it, no matter whether the numbers have changed or not.
Difference, it makes no difference, is no difference. I'm sorry, Cameron, you were saying something snarky about.
No, I was just telling York, we're just trying to give you some ideas. I'm curious which ones actually give you a hint or help or.
No. So this is these have sort of been my general understanding. I think that the main challenge is sort of translating that general understanding to like, okay, what would this actually look like code-wise? What did happen sort of as part of that thought process, I basically took a step back and sort of asked myself like, okay, why am I doing incremental compilation? Why do I want to do that? And the answer is, well, LLVM is slow.
LLVM is slow, yeah.
And the thought there is, well, at some point, I want to replace that anyway with something that is not slow.
Yeah.
And the second point there is I've always been not a fan of using caching when the underlying thing can actually be made faster. This thing, for example, GitLab or really any web application, and an approach often taken is like, hey, this piece is slow, let's cache. And like, well, maybe let's figure out first why it's slow and make it faster. Because otherwise what happens is it's fast when you cache it, but then the poor bastard who runs into an uncached version gets this horrible experience where it's like incredibly slow. Now from that I said, okay, what if I were to say magically replace the LLVM backend today with something else? Would whatever time I spent doing object file caching matter? And that's why I sort of ran some quick numbers a few days ago. I was like, okay, I have, I think about 13,000 lines of code for my standard library plus tests. That takes, I think it was like 2.5 seconds, whatever it was, to run. 80-something% is LLVM. So if we get rid of that, I think we were left at like 200-300 milliseconds, whatever it was. And then said, okay, if we sort of increase that, we assume a linear scale. We go to, let's say, 500,000 lines of code. Plus optimize the compiler a bit more, do some things in parallel, that sort of thing. I think I got it to like 1 second for 500,000 lines of code. That is everything except LLVM. So parsing, type checking, specialization, potential optimizations, etc. And that was like, okay, well, 1 second for 500,000 lines of code is actually not bad. Especially considering I don't think anybody will be writing that amount of code in Inko in the next 10 years. So that's where, at least today, I've been looking more into replacing LLVM, trying to figure out, hey, this alternative crane lift, is it viable today, like it wasn't a year ago? And crucially, what would the actual steps sort of roughly be in terms of like, hey, I call this function in LLVM, what is the equivalent in crane lift? Because basically what I don't want to do is spend, let's say, 3 weeks building some sort of incremental compilation system, 6 months from now replace the backend, and then find out incremental compilation isn't actually relevant anymore because now it only saves us 10 milliseconds, woohoo, but we do have the code complexity there. Versus maybe I can spend a couple of days replacing the backend and basically buy myself a couple of extra years of not having to deal with incremental compilation, and through that hopefully being able to do parallel compilation. Because as far as I understand, LLVM does have some degree of support for multi-threading. I vaguely read that you need to flip some compile time switches for that. But crucially, the wrapper that I use doesn't support this at all. The way it's sort of structured, it uses types that are not thread safe. Been requested, but probably not going to happen anytime soon. Whereas, as far as I understand with Crane Lift, it, by virtue of just like it scopes things per module, but beyond that, as far as I understand, it doesn't use any shared data structures. Meaning that, for example, generating the object files is something that is embarrassingly parallel. Like you can just trivially do that in parallel, meaning that, yeah, it might completely nullify the need for incremental compilation at that point. So that's what I'm currently looking into. But
what kind of parallelism? What kind of parallelism am I looking for from LLVM?
So for me right now, it will be a very high level form of parallelization where I take my my IR, which is basically scoped per module, and then I turn each module in LLVM IR and I tell it, hey, run your pass manager on that module, and then serialize it to an object file. Ignoring the fact that this wrapper library doesn't support it, it would be nice if I could do that module lowering in parallel at least. But I haven't been able to find any sort of clear answers if that's actually possible in LLVM.
So you can easily run you can easily process different modules on different threads. They will all have their own context, etc. I guess if you want to link them together, there will be some like serial points, but I think it should be doable. But it's not done by like tools that are available in the LLVM. You just have separate threads, they have separate contexts, and they just don't know that others exist. There will be some issues around shared state, like command line options. If you want to change them separately for separate threads for separate compilations, that will be problematic. But yeah, that's the extent you can do multi-threaded stuff with LLVM, as far as I know. Maybe there are other ways.
Right. Okay, well that's at least a bit more reassuring. But that's kind of the annoying that because I go through a wrapper that doesn't support it, it's like I can't really work around that. But then sort of extrapolating from there, in a future version of my compiler, I can see there's definitely more room for parallelization. Like parsing is currently done sequentially, mainly because I just haven't bothered doing it in parallel. But certain optimizations could be done in parallel. Like if you have, for example, if you take inlining as a whole is probably quite tricky because inlining one function may inhibit inlining another. So if you do that in parallel, you may end up a case where you want to process one function, but you have to wait first for another to finish.
Did you need incremental compiling with optimizations? Or were you expecting it's incremental only for debug?
Just in general, like always.
Why?
Okay, because I was gonna say a bunch of things and mention TCC, but TCC doesn't do release or optimize.
Yeah, and I don't compile to C either.
It's not that hard, but it does take like a couple of weeks.
3 days. 3 days.
I'll still say that negates or Yasser's quick is incredibly good at what it does. Like if you really need a target and are willing to put up with some bugs, like it is like 50 to 100 times faster than LLVM at just like generate the code, and there's just no globals used, so it doesn't have like you can do everything in parallel, just create separate modules and it works.
We're on Linux, I think.
What?
I think Yurik and I are both on Linux. The Asterisk code
Okay.
doesn't support Linux, right?
No, I use it on Linux, FreeBSD, Mac OS, and Windows.
Oh, I'm out of the loop then. I'm
Oh, he got
totally
Windows
off.
too? He got it.
Yeah, like he started on Windows, and I do my code generation mostly on Linux and FreeBSD. Although sometimes I take my little MacBook around and use it on that, but I have to emulate x86 because the ARM backend isn't quite ready for TV yet. But still, it works quite well and is significantly faster to compile. And it's just like a few C files that have a very simple C API that you can bind from like whatever language you like, Rust, whatever. It's just not hard to add to projects, and I have been enjoying it. The compile times are something along the lines of like 52 to 100 microseconds per like module that I have, and my modules are just single functions because I'm doing incremental too. But yeah, I use it as a JIT backend for just-in-time compilation, and it works fairly well. It just does what it says it does. It's fairly simple, but I don't know if it's ready for like Inko yet, but still, I think it's a very good option if you're looking for just like a very simple backend. I don't know. That's just
Yasser
I have
seemed
found.
pretty
Yeah.
available too, if you wanted to talk to him about what it would take.
Oh yeah, he's always bugging around on the Discord and on his own Discord and everywhere apparently, just talking about it. And like you ask him to implement a feature, and it just magically gets in there, and bugs are fixed really quickly. It's really nice. He does a really good job and doesn't write code like LLVM does. LLVM writes their code a little bit confusingly. GCC has even started to recently, but like CraneLift is a little slower than TB in my experiences. I haven't used CraneLift properly, but like seeing the speed ups from CraneLift, like TCC compared to like Quick, the TB's C compiler, right? And then Quick compared to like a CraneLift based anything is about the same jump. It's not like it does optimization and it does it really fast because of like sea of nodes stuff. But anyway, yeah, I don't know. That's just what I've gotten success with. I barely need the caching anymore because I'm like, oh yeah, we can just compile faster than like the startup of other things. Like by the time you're done like translating the Lua module into like IR, my virtual machines IR, it's already started running the first block of code and doing stuff, which is nice.
Do you have some numbers on runtime performance of the generated code, like compared to, I don't know, LLVM 02 or 03, something like that?
Well, since my language is a Lua virtual machine, my language runs Lua. I can say it's probably better than 01 LLVM, but worse-ish than 02. Sometimes it can beat 02, but 03 it's blown out of the water by LLVM. But it's I wouldn't use it as like I wouldn't use it as the like last tier of JIT or the first tier. I would use it as like an intermediary. Like you've interpreted the code, got a little profiling information, you've got a little type information, turn it into TB, and then once you've got a bunch of TB together, maybe then compile into LLVM because I do just-in-time compilation stuff. But if you're ahead of time compiling, it should be a good like we just want one thing recompiled, and it makes just normal O files. So it just you can put code into a buffer and write your O files, and it minimizes the amount of linker work that happens, which is one of the neatest things. Is if it sees two functions that are in the same module, it won't ask the linker to link them together. It'll just link them together itself. Because why would you ask the linker to do that? You're putting so much work on this poor linker when you could just do it yourself, and there's no need to not. Yeah, yeah.
Yeah.
And it avoids like longer jumps and stuff like that. You can do like better optimizations on it too, but even when it doesn't. But either way, it's I like it a lot, and it's just like a few C files you have to compile together, and I think Rust binds to C fairly well. I don't know. If it's anything like Zig or Rust from 3 years ago, it should be fine. It should just be like, hey, add these 3 C files to your project and a bajillion header files, and it should just compile together and doesn't have any runtime dependencies other than like a libc. So yeah, it's fairly good. But Yeah. I'm just saying, like, I've started to not believe the LLVM people in saying why it's so slow, because like, is it really that hard to make a decent, not a great compiler, but like at 01 or 02, does it really need to be that slow?
They
Do we
got
really need to
IR
do all these
issues.
things?
They need to sort their IR out. That's their
It's
problem.
not a pointer, it's a pointer to I8. No, we can't do anything about that. No, we can't do any optimizations based on this extra I8 information. But it's there, you have to type it.
All right.
No, because that's the thing for me. I compile with the equivalent of 00. There's a option to do 03, but even 00, like that's these times 00 is 2.5 seconds. You do 03 and it runs like an extra 5 seconds, but there's no noticeable performance difference. That's a big part. There is I don't feed much specific. I don't annotate anything in the IR. So what LLVM gets is this fairly opaque IR. So it just goes like, well, I guess I'll do this.
Can't do anything, yeah.
Yeah, so then
which is, of
case,
course, big part my own fault. But it seems that even these stores where Rust, they do pass all that information, and even a simple program, like maybe a bit more than Hello World, but a simple program can still take a few seconds to compile.
Yeah.
So, and if your goal is to squeeze the last bits of performance of the generated code, LLVM does pretty good job. So that's how we're using it. And well, yeah, it takes long time. It takes like almost order of magnitudes slower for our LLVM based compiler compared to C2, but we are beating it across the board at the point.
No, and I think that's what it makes sense for it. So there's some people, for example, working on a crane lift backend for Rust, specifically for debug builds. The idea being that for debug builds, you really don't need the raw LLVM performance. You just want something that compiles fast and runs like okay enough. And I think for these specialized workloads, that makes sense. We have a hypothetical option where you say compile with LLVM, and yes, I am okay with this taking 10 times slower.
But also, I think you said an interesting thing, that you don't provide that much information to LLVM. I think that is an important bit, and in order to get good performance, you need to communicate a lot of the information about your language, about your semantics, so LLVM can take advantage of this. So it's not kind of a plug and play where you do a simple lowering and you get good performance. It's you need to craft the IR that you produce carefully. You need to tune the pipeline, but after that, you can get good performance.
I've been wondering, do you know why GCC has similar performance to LLVM? Because I heard most compilers can beat GCC, like a couple years ago, but I never seen LLVM beat in performance in anything.
Like compile time performance or like runtime performance?
Execution time.
Execution, yeah.
Oh, okay, yeah.
LLVM just throws all the bells and whistles at it. You try hard. Cost you a lot of time.
I think both compilers are pretty much like basically state of the art for C++. In some cases, one is better. In other cases, other is better. I think overall, we are probably in diminishing returns in terms of performance. So no major breakthroughs on the horizon. So they will be.
Okay, so maybe what I heard was GCC like 10 years ago was easy to beat. Maybe that's what I heard.
That was my understanding of 10 and 15 years ago. It was a good lower bound because it had raised everyone up, but it was not hard to beat. And then people were beating it. Yeah. And maybe it's caught up greatly. I don't know. I haven't been coding C code in the last almost 10 years
GCC
now.
has gotten a lot slower, like at compile time too. They do a lot more things now. Like they added a new intermediary representation. They added new front ends. They're doing a lot of hey, we aren't the best. How do we be the best?
I never heard of that, but I did run some tests like a couple months ago, and it's actually pretty fast. It's if you give it C code, it's as fast as Go.
I thought Go wasn't super hard to beat either.
Yeah, Go is not like.
No, its
Okay.
compile times are pretty decent, generally, in my
Go's
experience.
compile times are decent. That's what I've heard. And
Its runtime performance is okay. I'm not an expert, so take my opinion with a grain of salt.
Me either. It's not fair.
But from what I gather, it's a bit disappointing in the sense that I think recently they announced this thing where they were going to do function inlining, for example, or a bit more inlining. Again, I might be mistaken here about what it actually was, but I remember reading it and basically think like, wait, they were not doing this before already. That's a pretty crucial thing. And
yeah, I was talking about debug, by the way.
And up until recently, I think they're or maybe they still do it. They were very, what's the right term? They didn't try very hard to put things into registers. They were just using the stack much more often than necessary for, I think, function arguments.
They're not backed into LLVM. They're just their own code generator.
Yes, some Plan 9 relic.
Plan 9 relic, holy crap.
That's well, the early version, they basically took the Plan 9 tooling and they were like, this is Go.
Wow, I didn't know that. Okay, fine.
But so as far as I know, at least the runtime performance of Go, it seems to fall in this area where it is generally good enough, but it's not great to begin with. But I think the important thing there is if the people using it are happy with it, then it's like, yeah, what's the point, right? If it's the equivalent of, say, 01, if people are, well, it's fast enough for me, and it's like, yeah, doesn't matter.
So to clarify, when I said GCC is as fast as Go, Go, I don't know if you can tell it to use a single thread, but it will automatically spawn a few threads and try to use your cores. It doesn't do it well. Like I try to measure it with GCC using like multiple processes. GCC will destroy it if you have more than one GCC process. For a single process versus Go, which is using many threads, they're roughly the same. And this is debug builds for both of them. When I measure compile speeds, I always measure debug. When I measure optimized builds, I'm talking about runtime performance because who cares how long it takes to build.
But I do, but it's I mean, that was the philosophy, was the blending of the two, the cross product or whatever.
Well, that's a JIT.
Fine.
I did have a question about escape analysis, but maybe this is boring because no one here likes C, except for maybe two of us.
I'm sorry, I do escape analysis. I'm interested in escape analysis. Not necessarily related to C though.
Okay, so assume that you forgot to write static on your function, meaning that it can exist in another object file. So let's say I have parse int as my function. In another function in the same compile unit, I call parse int and I pass it a pointer. And I noticed that I did something like this, and because I modified the pointer after the function call, it didn't it didn't do a tail recursive call. It was something weird. It had something to do with escape analysis because I touched the pointer after the function call.
Okay, wait.
I was like,
where did tail recursion show up in this story? Because if function A calls parseInt and function calls the parseInt function.
Okay, right. Okay, so I think the exact code I had was I had a file called parseInt, and parseInt was going to be recursive. I think to handle the negative. So if it saw negative, it would just call itself with a positive value.
Right.
And then it would just and then the out buffer, it would just add like I think it added one to the pointer, and then after the function call, it added the negative. So that's the
You're
touching
talking
of the
about
pointer
printing an
after the
integer or
function.
parsing an integer?
Maybe I should just write this out in the Google
Because if
Doc. I
you're
don't have that opened.
all right, see you,
Um,
Shaw. Yeah, if
I sh-
you print an integer, you might want a space for a leading minus. But if you're parsing an integer, your result goes into an integer register, not a buffer.
I guess, I guess it was printing it. Yeah. Okay. It was printing it. Yeah, it was a couple months or
So, right,
6 months ago when I
your
wrote the
print
code.
function says somebody gave me a buffer. If I see a negative number, I slap down a minus and I recursively call myself with a positive version.
Yeah. Yeah.
Okay.
But if I did the negative before the function call, everything would just it would just not even do a tail recursion. It would just do a jump and everything is fine. If I did the minus after the function call, it would store a bunch of registers and then call itself. I
Right.
think that's
Make the
what
actual
happened.
recursive call.
Yeah.
Sounds like the
And
other
I
one
thought
you
that,
managed to sort out your inlining. Yeah, well that goes
yeah,
too.
so I thought that was very weird because it's I know it's recursion might be a little bit hard for the optimizer because it's calling itself.
Yeah.
But I was just wondering, why did touching the pointer do that? Like, is there some kind of like
So
C rule?
you have enough stuff going on, Levo, that you'd have to write the code and we could take a
Yeah.
look
It's
and
not
then I can
it's
tell you
not
'cause
that it's a pointer, it's that he's using any of the variables, so that disables the tail call.
right. That's what I'm trying to get at. You have to look at the code to see what it is. It's
Okay.
not necessarily
Let's change topics and I'll see if I can write it out in the next 10 minutes.
so you can go find the code. And then the real answer, of course, is don't do that.
Okay,
Just
next
put a fucking
topic.
if statement up front.
Somebody has a topic.
Sign, go again.
Hmm.
All right. Yeah, I don't have anything ready here. I haven't looked at
Some maybe.
I haven't looked at simple in 2 weeks because COVID got me and I've been doing stuff with ecstasy. So whatever. No excitement here. All right, we're all dead now.
Next topic.
Yeah, exactly. We get an update from Adrian.
Yeah, sure. So yeah, I've been like, so just in case people don't know, but I've been working on my language, which is geared towards writing operating systems, and I made some good progress. So I don't know, last time I talked about it, basically nothing was done, but now I can actually compile decent things. Like I have function calls, basic memory reads and writes. I have arithmetic records.
Register allocator.
Yes. I basically I'm at RISC-V currently, and yeah, I do no linking. I just go like straight output straight binary, and it works quite well. Like the throughput is through the roof. I can generate currently like 7 million lines of code per second, like binary, which is 150 megabytes per second per core, which is nice.
Faster than mine.
Yes,
yeah,
but
quick. Yep.
the type system is like very, very simple. But I experimented with some things like unsigned integer promotion. So I think that's a cool thing. Like being able to pass a U32 to a function that expects a U64. I think that's not even a foot gun, really. Yeah, like yeah, and also I've been working a bit on this performance challenge from Cliff, and in the process writing a bit of C and C++, and holy crap, the defaults are horrible. Like anything relating to pointers and numbers or any like it's crazy how many times I stumbled upon UB. Like the most recent thing was actually shift UB. That's something I mentioned in the Discord. Like the fact that I can like shift a byte by 10 to the left because I switched from U16 to U8 in some refactoring, and then suddenly it's UB and my whole code blows up and memory is corrupted. or like other things. Yeah, that's pretty nuts. But unsigned integer promotion currently like feels very good. And yeah, other than that, I think like this ISPC thing that I mentioned last time, I think that's like the ideas are pretty cool. I'm trying to understand better how to guide the compiler into doing the right thing and how to not mess up like loops.
I
Yeah,
lost
sometimes.
Wait, I lost a few feet
do
to
you
the
guys hear me?
intel. Oh, you locked up for a minute. Go again.
Sorry. Yeah. So sometimes sometimes I would mess up a loop because the compiler decides that the thing I'm computing or loading from memory in the last iteration can be used later in the function and decides to cache it inside the loop, but thereby emits a few instructions that are not necessary, something like that. Yeah, and there are some other things. But I don't know. I feel like this implicit SIMD stuff is really cool. So I definitely want to include that in my language. Right. Yeah.
So, this is you done your own code generator from hand here?
Yeah. The register allocator is horrible. So basically, it's just I wanted to avoid doing any kind of visiting and building any kind of AST. It's a single pass stuff, and I'm just like taking the first free register that I can find, using it. Then temporaries get like freed after each statement. Yeah, so I can like
And
compute
nothing
expressions.
special around loops with registers.
Yeah.
Yeah.
And right, and for function calls, I like do a quick diff to see which like I'm not exactly sure I like what the best or most efficient calling convention is I should like go for during code generation.
Gonna do
Yeah.
garbage collection?
No garbage collection.
Yeah, it's an OS thing. Yeah. Then you split some in colleague color and just crushed registers. And you went inlining of small functions.
Yeah, I'm pretty happy with like inlining. I mentioned it before, but just because everything is like compiled in the order it's declared, so many things are like I don't know. Just the compiler design feels easier, and inlining is just a mem copy, but I need to strip out some things and then patch registers. So that's kind of cool. Yeah, and there are some, but yeah, basically that's it. And
There's no optimization at all. So
yes,
right.
it's pretty horrible.
No, I'm just thinking through. You can do a mem copy because I did a mem copy when I was doing fourth compiled system for inlining, but we're talking 30, 40 years ago. Nothing fancy at all. Yeah, sure. Trying to think if there's any quick advice to help with things. The only thing that usually happens in these scenarios is you have really bad register allocation. It's the typical story.
Right. It's kind of cool. I mean, there are lots of things I thought to like incrementally improve this current state. Like first, I can decide to like on a granularity of a function, basically first compile everything or it goes through to the end of the function and then do a reverse linear scan, and that should give me much better register allocation. Just compute the
Live
liveness.
info, yeah. Another one
Right.
is track loops somehow. However you track, I don't know what your language looks like. So you track a loop, and then clear registers out, or be prepared to clear registers out before a loop, and try to just register everybody in a loop.
Yeah, and I've been using a lot of do while loops. I love them actually.
Do while, oh my god,
yeah, they're
do
awesome.
while loops.
Yeah.
My brain does not like do while loops. When I generate code, it's always a do while loop in the end out of the optimizer. You know, he puts the branch to the bottom of the test and branch to the bottom up to the front. But when I'm writing code, never.
Do while false can be handy.
Oh geez, I don't even want
Yeah.
to.
Eventually, I was thinking of so basically, right, like my medium-term plans is or medium-term plans are because I actually have I have a kernel written in this language now that can actually boot on QEMU. So you have a little hello world.
What are you booting on?
Just some
Raspberry Pi
QEMU
thing.
virtual. Yeah, something like that. It's a like a generic RISC-V SBC. I think it doesn't have a name.
Okay, fine.
Right. And yeah, it's quite nice. So I can do that, but so now I have like a very, very basic C-like functionality. But the thing I'm very interested in is like compile time function evaluation. And for that, I was working on a prototype to like basically using binary, what is it called? Yeah, binary translation from the target language to the host language to get compile time function evaluation instead of having compiling two versions of a function. I just compile everything to the target CPU, and then if I need to evaluate something at compile time, I just do binary translation. And this can be done very quickly. Because since I already have it compiled, everything is like that done in a single pass. I feel like this could be interesting. And then I don't need to have any kind of bytecode or like an interpreter or something. That's usually how compile time function evaluation is implemented.
But you have no safety then if the
No. There's no safety, and that's how I like it. So yeah, during compile time function evaluation, you can do everything. You can like corrupt everything.
Gotcha.
Yeah, but for safety, like I was planning. So also there's another thing about like safety. I kind of get a bit of an existential crisis when I see that people are talking about legislating memory safety and all these like I don't know.
What?
There's laws being passed. I think in a few months or something in the US that the Department of Defense is not going to be able to like purchase any like memory unsafe language software or something like that. I don't know. There are some political pushes towards that. So I kind of started to get familiarized.
Well, that
myself
would be
with,
hard. That would be
yeah.
hard, of course.
Yeah,
I tried to.
haven't heard this. This seems like madness.
Yeah, I mean, maybe it's people are exaggerating, but I kind of try to look a bit at mutable value semantics because I do want to stay away from borrow checking, like or at least like lots of lifetime annotations.
Right.
Like because I think returning references from a function and storing them like just for the code I write, or a lot of times I actually don't want to do that. So I feel like these mutable value semantics, at least how they're implemented in some languages, already offer most of the benefits. And then in the end, you will always be able to use unsafety features in the end. So yeah, that's like kind of my escape hatch. If like things get really dire and I'll be labeled a criminal if I keep working on my memory unsafe language, then yeah, mutable value semantics is my escape hatch.
Oh, I cannot imagine anyone could ever say that what you're doing is illegal. It could be that it's intended as an academic proof of concept. And as soon as you have, fair use rights, Linux and every OS on the planet will be an academic proof of concept, use at your own risk, not intended for, and it won't matter. It's fine.
Right. But yeah, compile time function evaluation is a big one. And then eventually I also want to look at, I mean, just this MLIR vector dialect and yeah, I guess getting familiar with that. There's some like nice running meetings like weekly or bi-weekly on MLIR, and yeah, there's some like cool projects like it's very machine learning focused, but it doesn't have to be. I can still benefit from it because in the end, I just want my code to be vectorized. Yeah, doesn't matter.
You want your
what it's
code to
used
be
for.
vectorized, or your compiler to parse the input, or what are you vectorizing here?
What just the code I intend to write in this language is supposed to be gonna go fast and make use of both SIMD, but maybe also accelerators or compile down to like FPGAs or something like that. Yeah.
Okay. This is all on RISC-V. You got some RISC-V project money from somebody? It's like helping you.
No, I'm doing this on my side, and like I purchased a small like a small SPC. It's in the other room. Yeah, but I haven't gotten around to booting it. But the thing is, eventually, this will be my dream. I just want to have a server rack or something with a few different CPU architectures and just spend my whole day testing stuff on these machines.
Yeah.
But currently, like the state of my compiler does not justify yet such a purchase. So I need to make some progress.
I think somewhere on my bookshelves behind me, I have every chip architecture book from the mid 70s to mid 90s or something. It was all my, hey, this is a cool chip. I like this chip. I like that chip. And then chips never showed up, and then Intel won the day anyhow and crushed everybody. You know, it's just like sadness.
I have my example mostly
Fire
ready.
away.
So it's not complete code, but you can see what I'm talking about.
Can you share
So
your
if you look
screen?
at it's on the Google Docs.
All right, let me share the Google Doc with the camera then. But go fire away while I sort out the screen share.
Okay. I couldn't find my complete code, so I just wrote up what I
Quit
remember.
making excuses. Just go. I to
So-
A. Yes. Okay. So ASCII print.
Okay. So if you look at buff square bracket 0 equals -1 or minus, yes. So for whatever reason, if you move that line above the function call, this will not do a recursive call and it would not save resters. If you leave it where it is, it dumps, it just like preserves like 2 or 3 resters and then it does a recursive call. Or maybe it doesn't even do a recursive call. I don't remember. But
One of them's doing a jump and one of them's not.
yeah, so this code right now is the bad version. Just moving this up, moving the buff up to before the function call is the good version.
Right.
I was just wondering if there's a reason, maybe the C standard said something that disallowed you to having like good escape analysis, but for whatever reason, this.
I don't think escape analysis has anything to do with this.
So why is moving the buff up one line gonna change
Because your
it's the same function.
+1
Because I'm moving the buffer pointer up by 1, so I have space to write the negative.
No, what's the res +1 for?
The function always returns the amount of bytes it written. So I'm adding 1 because I'm writing the minus.
Didn't understand the return value is the count of bytes written.
Right,
Yes,
but-
fine. No, it's because you have a tail call. You have a store on the tail call after the last function call.
Right.
You move the buff store up, you get a write out of the way, and then you have a classic tail call except for the +1. So he can do it with a jump. That's not an optimization I would do. I just fucking inline.
Why couldn't the optimizer just hoist the right?
Oh, because
It doesn't know what happens
then
inside.
he has to do escape analysis where he validates all the offsets that are written into buff by the recursive call don't get stomped. So you leave buff where it is. So whatever got written into buff by the I to A call, the recursive I to A call got stomped by the -1. Now, if you want to move it up, you have to prove that the I to A call won't ever write to buff at 0. Now, if you and I, we see it's obvious because you say buff +1, so buff at 0. But the rest of the I to A call not shown, maybe it has a place in it where it has a negative offset. It writes into buff. And as soon as he writes to buff -1, he crushes your minus sign. So the compiler would have to prove something exciting about what offsets are written into buff.
And it's GCC, so it's not going to do that.
Well, yeah, right. A lot of folks won't do that.
I think Clang also didn't do that. So I was just wondering, is that like a hard optimization? Because I thought it would
it's a
just
hard
be
analysis.
simple enough.
No, you didn't show the rest of the code that counts. The rest of the code seen below is the part that counts. That's the part that says, I wrote into buff at some math. Prove that math doesn't go to -1.
Or max.
or maxent and wrap
Yeah,
or
to
any
wrap
number of
around
things.
or yeah.
All kinds of bizarre shit. Hey, I handed you a buffer that contained 1 billion bits, and I handed you a value that was beyond the size of the moon, and now you just iterated as you go. Did you run off my 1 billion bit buffer and wrap? Go prove that. That's a hard proof. So your expectation is I'm only handing in values, obviously, that are 64 bits or less. I'm only doing reducing operations down in the buff call where I divide by 10 and take the remainder, and you're not showing that, but some reducing operation. And so the value continuously shrinks, and so it runs out after 64 iterations max, and you only write 64 bits into buff. Okay, actually you only write like 10 or 12 or whatever the number is.
But just to be clear, the
doesn't
fact
matter.
it's the fact that you do a write
Yeah.
to
To
a
share the memory
parameter.
buffer.
Yeah, like
Yeah.
right. So you're holding on to something, calling something recursively, coming back, and the thing you hold on to, which is buff, you're now doing a write to. Like very few compilers will tail call that.
Yeah. Or
Okay,
know that
yeah.
you could move to tail call, you have to move the write to buff ahead of the recursive call. And then you have to look at the recursive call and decide that it'll never stomp that location.
But the other problem, the code that you wrote here won't work because -9 will appear as not -9.
Oh, because the
Will
other
it?
guy? You have a why?
Well, because buff 0 equals 0 plus val.
No, but that's already been incremented.
Oh, I
So-
think I see what you're saying. Yeah,
Yeah.
this is just like old.
Yeah, I know.
Old
I'm
code I
messing with
found.
you. Hey,
Yeah.
you're playing around. I got it. I'm just running the code in my head and getting all sorts of funny things.
Yeah, it looks a little odd. And why do you have double parens around val less than 0? Don't answer that question.
I found more code. I'm gonna paste that in
And
just
how
a
does
moment.
count digits work without actually doing divide by 10 already that you're trying to print?
Oh, there are lots of optimizations for that one. So the
Really?
fastest, if I remember correctly, the fastest itoa is a power of 2 divide and conquer, not power of 2, half. So
Oh,
basically, you take the number. So you have some number of digits. You say, is it less than that value?
Yes.
So you have a constant value. You say if it's greater than that, I'm going to do one division modulo to separate the
Yeah.
left half from the right half.
Right.
And now I'm going to do them independently. I think someone posted some of the test results from some of these on our discussion
In the
on
land
Discord
of-
a while back.
The land of C2, I implemented the divide by an integer constant as a multiply add of 2 integers.
Those are amazing.
Get rid of the.
My brain can't deal with that
There's a
stuff.
paper, and you go implement the paper. The paper's comments to the reference to the paper in the source code hotspot on the divide place. That's
No,
where I
it's-
find it. I go to my hotspot source code and I go
It's
look up
just
the
super
div-
cool that you can do that at all. But the other one is the if you want a real challenge, Levo, do fast formatting from IEEE 754 binary radix floating point
No.
to strings, because that's so actually in a bunch of financial. So
Yeah.
I worked in financial services a lot, so a lot of financial services apps. Once you solve the, don't hit the database problem, the second biggest thing is F to A.
Yeah.
And it's ridiculous. Like we were putting pages together in like 200 milliseconds, and like 180 milliseconds of that was F to A. So
It's actually pretty
Cameron.
fascinating. Can you like in the future, can you give us more of these examples of like these challenges? I find them fascinating. Like yeah, this F2A formatting.
Like my log file challenge.
Yes, also this log file stuff. Yeah, anything like that. I think.
So the interesting thing is these guys, this was Capital Group companies years ago. So they found this paper and some sample code of how to do a fast F to A, and they actually implemented it in Java. So we're talking like super high level code, right? And it was faster than Java's native F to A implementation at the time.
Oh, the native Java original one for everyone today was soft float. It called out to the archaic soft float library. Did a
Interesting.
bit perfect answer and also had, essentially no optimizations. I don't know. Somebody wrote it eons ago as a proof of concept for how you dealt with writing, floating point, and somewhere in the Java brain people said we had to have perfect floating point. Can't do any. Must be bit perfect floating point, no approximations. And of course, the x86 at that time had all these cool, fast approximations in hardware. But to get to bit perfect, you had to wrap all those fast instructions with butt tons of edge case condition counting bits, which no one mostly cared about. And if you had well-behaved floating point numbers, none of that made any difference. So if you could get rid of the extra edge case conditions, you get a big speed up. In fact, C2 did a bunch of that stuff at some point. I went down that line. Not for the I don't think for the F to A, but for the sine, cosine, tangent, arctan, log, exponent. I did a bunch of optimizations at C2 level to get rid of the edge case condition checking.
So one of the things we tested that actually turned out to work well was while genning a page, we would create a cache of floats keyed by float. So custom primitive hash table, if you will, keyed by float going to string. And so we'd cache every string render in this table. And again, that's where we picked up the last. So first we did the F to A replacement. They built that actually in Java. That was faster than the Java formatting one. And then we would cache the F to A results. And that actually was ended up being the winning solution.
Cameron, I just noticed that the first example, it does catch negative because I did an unsigned typecast against value. But anyway, the second example, I was just reading through it, and then I just realized that unless it goes to U counts digit tables or even my other U counts, which is not using a table, it doesn't 100% know if it's returning a negative value. So I could kind of see why the optimizer wouldn't know if this
You need
goes
to write
negative.
yourself an optimizer and learn.
Actually, so you're right on the unsigned one. I was thinking magnitude, not bitcast. Good point. So I'll throw another one at you. Negative, where you say res equal I to A of negative val is an infinite loop, because negative val of negative maxent is negative maxent. So I only know these because I've been bitten by them. So
yes, I've been bitten by them before.
And I'm not really smart enough to actually avoid getting bitten by a lot of them repeatedly. So
Joshua Block and polygene lubricants.
What?
It was the string polygene lubricants, or one variation of the string. And he throws up as a Java puzzler, and you run the Java hash code, and it returns negative maxent, which you then run the hash code through an absolute value function.
Right.
And index it into some hash table. Well, absolute value of negative maxent is negative maxent.
Right.
And then the hash table explodes with a negative index. And you're like, how the fuck do you die with a negative index when I took a string, a stupid string, and I hashed it? I do absolute value, mod, hash, and explode. And you're like, what the hell happened?
You know what, Cameron just reminded me of something. So about the maximum negative value, that's exactly why the second function calls the unsigned unsigned count digit instead of recursively calling itself. I completely forgot about that, and that bug bit me at least twice.
It is neg.
So that's why I'm calling unsigned, so I don't have to worry about the maximum negative value. I mean, not the maximum negative value. Well, actually, yeah. I don't have to worry about the highest bit being set and nothing else.
I'm looking at this code. You got native maxent. So you decide that you're negative. So because you're negative, you do this. Well, of course, it's still maxent, but now it's considered an unsigned value, and you throw the negative down. I don't think it still gets you the correct answer.
So
Also,
the
you have a cast of U64, but Val's already a U64. Is that cast doing anything? And then you
it does work
on
but I
negative
don't.
max on min int.
Yeah, that's one of my test cases.
Okay. I'm
Yeah,
curious
I
what it
just
does.
feel like I'm
Okay.
not ready to explain it because I just haven't looked at the code for months.
Fine, fine. Java will do the div mod of the divide reciprocal, sorry, remainder in the one go function, except that I'll pick these up instead and turn them into integers. 100 specifically, 10, 100, 1,000 are specifically caught as multiplied by constants and add in order to make it work. And it's for the same reason that Cameron's talking about. Integer conversion to ASCII and floating point conversion to ASCII show up all over the place in huge quantities. So they get highly optimized.
And it's ridiculously fast, but when you throw a billion of them at it,
it's
amazing how much.
Pretty soon you're talking real numbers.
Yeah. Exactly.
So when I implement memory safety, I'm probably
You're back
LLVM
to
probably.
win. Oh my God. I can't hardly wait.
Well, no. I'm not. I'm still gonna make the IDE very usable.
You do the IDE first, and the OS, and then your chip design. Damn it!
I don't know where that chip design came from, but yeah. So I got a question for Arthur. So I'm assuming that if I do a memory safe language, LLVM is not going to optimize much because it just assumes that it's going to be handling C, and they didn't put that much work into escape analysis and restrictive pointers and such. Like, would LLVM help me a lot if I have a memory safe compiler?
I would say there are a lot of ways you can convey some of the higher level semantics about your allocation, etc. So you can try doing this and get some optimizations out of the default pipeline. But then at some point, yeah, you will. If you want to take advantage of the semantics of your language and you don't have a way to express it using existing attributes, metadata, whatever, yeah, your choice is either try and express this, try to introduce ways to express what you need in upstream, and there might be other people who are interested in doing the same. Or you will need to resort to writing your own custom passes. So we do both.
Let's say, is it time for Levo rewriting LLVM? But you get Yasser's already ahead of you there, Levo. You got to work fast. Sorry, the IDE was fun, Levo. IDE in a day was fun. 3 days.
Yeah, most of the time it's just handling like balancing out the memory when you're editing text. Like that part for whatever reason took like 3 weeks. And everything else is just it was just like a lot of small things that took like a day or two or a week. Font rendering was over a week, and inserting like many
Wait. Starting your project of font rendering was over a week.
Yeah. GDB by itself took like maybe 2 weeks, and getting the other debugger took like less than a week, which was pretty nice because it was exactly the same as GDB. It's just adding a couple extra commands, and I don't know. It's just like I there's like only 2 things that actually took more than a week, and it took many weeks.
Only because we love you, Levo. And I'm at
Well,
least
I'm
excited to get
sick.
memory.
I'm sick of VS Code. Like I can't use that anymore. I gotta get my editor working well.
Emacs.
Yeah, I'm just gonna like want to do more, and then Emacs is not gonna satisfy me, and I'm not gonna
Don't
write
understand
like
what's wrong with Edlin.
I lived with Edlin. Don't go there.
don't think I heard of
Yeah.
that.
It was high school. I did Edlin in high school. Holy crap.
That was some Windows abomination, wasn't it?
It
Or
wasn't
DOS?
Windows.
DOS, Microsoft
DOS.
DOS.
It was DOS. It was St. Luke's Blood Center and the Houston Medical Center, downtown Houston. I was the IT guy in high school. And I ran the weekly jobs of who was going to donate blood and how to send them out, and printed them on a giant IBM crunchy line printer, and walked them down to the mailbox and sent them, and did
Yeah, see,
the,
in the mid 80s, there were no free editors. There was no Notepad.
oh
And so
no,
Notepad was a giant leap
it was a
forward. So
giant leap forward.
so
Sidekick.
all
Fucking
you had was
Sidekick.
Edlin, where you could edit one line at a time.
And you could
And
only roll through the file forwards. You could
And-
skip any
and-
number of lines forward, never any backwards.
And everything else cost money. So if you wanted something with the functionality of Notepad, it was $39.95 from Broderbund or something, you know. So
Oh, that didn't even show up when I was doing Edlin. That came later.
no, I'm
I
saying you
remember
could buy a package that would include a
Yeah.
file editor for 30 or 40
I think
bucks.
I paid for Sidekick, which included the Notepad editor of some kind.
Yep.
It had a couple other things in it. Yeah.
Back in the days of Norton Commander,
Yes.
which I never used.
Stop before I commit suicide. The bad old days, they were in fact bad. Fine. Some things may have been better. Some things were definitely worse. Fine. All right. Are we run out of things here? Are we dead now?
I have one interesting thing, kind of interesting. It's a bit embarrassing. I was so I decided to like, after finishing implementing this challenge with the parsing the CSV file, I wanted to implement it in assembly, just for fun. And the thing is, basically, I wanted to understand a bit better, like, the throughput of certain basic blocks, because like skipping to the end of the line, for instance, is actually 50% of the time. Like, that's where 50% of the cycles
Once you
are
get
spent.
everything else cleaned up, yeah, okay, yeah.
Yeah, and the interesting thing is, I was just curious about, like, if this particular instruction selection is ideal, or if there's something, yeah, to improve there. And I don't know. I did lots of experiments, and then I used these tools. LLVM has one, but there are also others, like, for estimating the, like, I don't know, the throughput and latency of like basic blocks. And yeah, I don't know. I stumbled upon something, and I thought I was a genius. You know, I realized that, wait a second, there's a stall here for some reason, and we can replace this with a better instruction, or something like that. And I don't know. I was like really happy, and I started writing about it, and then I realized that my basic blocks, I accidentally made a mistake. I switched destination and source register because I confused Intel and AT&T syntax, and all of the work I did measuring the basic block throughput was on nonsense code. Yeah, so that was painful. Yeah, so it turns out compilers are, like, the LLVM is actually pretty good, and I don't know what the hell I'm doing. But it's like a valuable lesson. So yeah.
So now I have to give my bit of advice for benchmarking, especially micro benchmarking. Invariably, I start thinking I know what the problem is. I just need to figure out where the time goes, what's fast, what's slow. And I go measure something, and then there's a confusion, and I'm like, this doesn't seem right, but it's easy to fix. So I'll go fix this thing. And then I realized I've had a bug all along, and I wasn't doing the right thing, and it was highly inefficient. Some special whatever wasn't working, and I fixed my bug, and the problem moves again. But then when I go back to remeasure, I realized it was a giant pain in the neck, and I hand rolled all this shit to go measure, and I have to go hand roll it again, and the setup takes forever, and I finally get the measurement. It takes however long, hour, day, week, depends on how much stuff. And then I go look at the results, and there's something obvious, stupid I've got wrong again. I have to go fix a bug before I can measure the right thing. And after about 4 or 5 passes, I realized that I'm spending more of my time getting set up to do the efficient measurement, to do the right kind of good statistical proper measurement, than I am actually hacking the code. And so then I spend like a freaking week to go set up. I can get a harness. I can actually measure reliably. And then it turns out the problems in the end, after I fix 3 or 4 unrelated bugs, something stupid, and I fix it. Oh, it's all instantly fast like it was supposed to be all along. And so I don't know the moral there is, except if you measure something once and you want to go then hack the code to go fix what you measured, there's a good chance that you screwed up measuring, you screwed up the code involved, you screwed up something nearby, you measured the wrong thing, you're gonna have to measure again, and you're gonna have to measure again, and you're gonna have to measure again. Spend some effort up front, getting to where you can just whip those measurements out so that when you start fixing bugs and you realize you're measuring the wrong thing and fixing the wrong bug, you can repeat a lot easier. Like, done.
Yeah, I noticed that too. I am spending a lot of time like getting the harness to work
The harness to work, yeah.
Because and also a lot of times like I don't know if I'm touching a lot of memory, I need to like pre-fault all the pages. I can't use the I don't know. I need to like modify the code actually to insert the right points. So I can't use like I don't know command line tooling or something and yeah other things. Like setting up the kernel to play nicely with my benchmarks. It's also effort.
For the CSV benchmark?
No, just
Oh,
generally.
just in
some
general,
experiences.
yeah.
Yeah.
Yes, yes. Well, you're in kernel land for doing benchmarking then too. Yes.
But yeah, it's funny. I don't know. Like I thought, I actually the reason I looked at the like these like CPU simulators that show you how how code moves through the pipeline is that I wanted to avoid writing benchmarks. I wanted to get like some lows. I wanted to get some signal, try to get some like direction into like if there is even anything to look at. And yeah, that's where I made a typo. So yeah, kind of funny.
Got it.
Happens.
All right. Anything else?
Yeah, I have a lot of tests, automated tests that measures like maybe 90% of my text editor. So I just hit a shell command, it builds everything, it runs everything, it clicks on like stuff on my it clicks on the editor itself, like with that xdo tool.
Oh yeah.
And yeah, it's I don't have to worry about making a mistake because I could just run the script, walk away, and get a pass fail later.
Yeah.
Very
No,
handy.
yes. I mean, for editors, there's some extra effort. Or any GUI interfacing, there's extra things you have to do. You have to go mimic the user clicky, and you want to be fast clicky. Yeah.
The one problem is because I'm depending on things like a debugger, which depends on a few other things. It takes many seconds for that to execute. So I only do this when I'm about to commit something.
Yeah. I have my time and place where I do.
Which data structure did you end up using for your text editor?
So my dependencies are GDB, for debugging, UDB because I kind of like the time traveling thing and it was very simple to implement. I use SDL and free type. So,
sorry,
and SIMD JSON.
what data structure are you using to store the text in memory?
Oh, I just wrote on my own because I know I can write my data structures without a problem. So essentially, it's I have more than one layer. So when I insert things, it only has to touch a buffer of like 12K or not 12K. I think I touch 4K at a time, and yeah, I only insert into buffers of like 4K or 16K, something like that. And then when I have an iterator to go across it because it's such a pain in the butt to not use an iterator. I didn't know that when I started out because I never wrote a text editor before.
Iterators are handy things.
It sounds a bit like an unrolled linked list. Like you're connecting like a chain of 4K blocks, or is it?
So
Yeah.
if you edit a line, someone in the middle, how do you handle the change?
So that's part of my editor. my iterator understands that and made me very happy that I chose the iterator. So there's like a side buffer. And the reason why I did this is because when you type, it goes into the side buffer, but when you hit a space or enter or whatever, it makes that as an atomic item that gets inserted into the history. So when you do undo, it has a place to look up the original data. So if I'm overwriting that string, I can undo and redo because that whatever you typed is in memory someplace.
You
So
keep a list of changes, but how do you keep the original file? So you replay the changes on top of them in some other buffer, so to make the change the original
yeah,
text
so
along with the changes.
when I load the file, I insert them as like 16K blocks, and I have a flag that says this is belongs to a file. Don't overwrite it. So when I do want to write in the middle of that block, it will copy a fraction of it. It's like I think I have it as half into a new buffer, and then it will write your new data in there. But by writing the new data in there, it actually goes to the insert buffer first, because every insert buffer is unique because it wants to keep it for the history. So it copies the insert buffer. When you hit enter, it copies or space, it copies the insert buffer into the buffer. And the buffers, like the 16K blocks, you can overwrite and delete all you want because all the data is stored elsewhere. It's in the string pool for the history,
We're gonna
or
have
it's
to
part
work
of the
on
original file, which
work on your presentation of data structures.
uh well, I don't have any slides or anything, and I'm
No,
gonna try to
I
explain it,
know.
but
Yeah, when you're hearing too many buffers,
I
nested
don't
buffers,
know of
buffers.
anything that does anything. I don't know of anything that uses something like this, so I have nothing to use
Gotcha.
an
Yeah,
example.
yeah.
So it's a bit weird.
But
No,
it's a
it's fine.
version. It's a version data structure. It sounds a little bit like NTFS actually. So, or for that matter, ZFS does something kind of similar.
Okay.
Yeah, I don't know enough about file systems.
Yeah, I mean the main thing is every version needs a root, right? So if you type 100 words, you have 100 roots because you have to be able to undo to the previous root, right? So you have a data structure that I'm saying root as a shortcut, right? It basically means if I give you the root, you can render the entire document to the screen, right? So if I type a word, I have a new root, and I want that root to use as much of the graph or whatever the tree or whatever data structure is beneath it from the old version as possible, maybe the whole thing, right? Type another word, I get a new one, type another one. So I keep building this. So now my undo is simply walking back those steps.
Yeah.
So the root itself is a read-only, it's a const object, right?
Yeah.
And that's how version file systems work, because Windows used to have the problem where if you shut off the machine or had a blue screen of death, which only happened every 7 minutes, you'd lose your hard drive and have to reinstall Windows because FAT was a snapshot only. In other words, if it safely wrote everything to disk, you're okay. Otherwise, you had to reinstall Windows, reformat your hard drive, buy a new computer, retire, whatever. So NTFS basically did a dual version. So basically, they had one read-only previous version, and I'm making a mess onto a new version. Oh, goodness gracious, what the heck
Zoom
was
has
that?
decided that you're in a party mode, and we're getting balloons running by your face.
That's hilarious. So yeah, so it did this bimodal thing where it had basically two roots. So when you would recover NTFS, it would look and say which one is the latest version that successfully wrote. And the way it would do that was have a hash at the beginning and the end of the page or something. It's years ago, so I don't remember all this nonsense.
It's double buffering. They're whatever,
double
two-phase
buffering,
locking,
right?
step over
And I
step,
think what
etc.
ZFS does is kind of an infinite number of versions, so almost a version journal. Anyway.
I had some data loss on Linux and kind of pissed about that, but yeah, I don't know what to depend on if you can't even depend on Linux. At least for file systems. You figure it's going to be stress tested on servers, but no.
I'm old enough to remember when Linux didn't work much at all, so I don't feel too sorry for you.
Things are definitely better now on that front.
Yes. Oh yeah. Oh yeah. Linux has grown up. It's pretty amazing.
I'm just thinking in general, everybody's OS, hardware stability and all that. All right.
Yeah.
Did you guys see anything about the OS2 a couple days ago?
OS2 is alive? I thought it died.
No. Somebody was just talking about why OS2 lost, and other people were saying it's that entire post was like bull. And yeah, did OS2 ever work for any of you guys?
Oh, I messed with it for a little
So
while. I didn't
OS2
try hard.
OS2 3.0 became Windows NT. So
Oh well, okay. I didn't know that.
so IBM and Microsoft had a deal
Huh.
where IBM would build the first two versions of OS2, and Microsoft would build the third version, and that would be the unified Windows plus OS2 into a single operating system. And then they had a contractor. He wasn't even a Microsoft employee, but he's the guy who made Win386, the memory manager for EMM inside Windows, to get 32-bit memory addressing into Windows without having to switch to OS2. The story goes that he gave a demo. It was actually over Christmas week. I think he gave a demo to Bill Gates and a number of the other OS and Windows developers. And Bill Gates looked at him and says, "You know what this means?" And they looked at him like what? And he says, F IBM. In other words, he realized at that point they didn't need OS 2.3.0 and they were about to screw IBM royally. And the rest is history. They named it. Well, that was eventually became the core of, or part of. Obviously, the initial was in Windows 3.0 and
I
Windows
remember an
3.1.
EMM.sys coming around
Right.
at some point.
Yep.
Oh geez, I didn't know that. All right.
Anyway,
History.
funny stories.
Fine. All right, I'm gonna try again here. Anyone else before I call it quits? All right. Till next week.
All right, see you guys.
Bye-bye.
Merry Christmas, happy holidays.
Yeah.
Levo, we'll look forward to the demo of the LLM on your new hardware.